All right, so pretty much this video is going to be on an update on that basic prototype of the auto watering pump. This is pretty much a pump set on a timer. It's an inexpensive way to set up, water pump if, you got to go out of town, or you like me, you just want to sit here and have to remember, oh yeah, I got to water plants every morning or something like that. So this is a pretty simple way to do it, and it should work for pretty much most people. Yeah, let's get started. All right, so as you can see now, I got the battery pack right here. It is dusty out here in the desert, so everything is usually covered in dirt or dust. Right here, we got the Arduino hooked up, and now we're just gonna fill this tank up. Still doing drywall for the cabin. I got some videos to upload on that. Next on the list is doing the drywall. I'm still deciding. The reason why I haven't done the drywall yet is because I'm still deciding if I want to do exposed or not exposed conduits for the electricity. The reason why I kind of want to do exposed is because I can switch up later and add more outlets, or upgrade in the future if, standard USB-A is not the standard anymore, and go from there. But right now, I think I'm going to go with the exposed outlets because it'll make it a lot easier, and I don't have to rip the walls back out to, upgrade the wiring and all that. So we'll talk about that another time. This is something I 3D printed, so it holds my phones and stuff like that. So this is my development phone right here, and pretty much what we're going to do is we already have the pump hooked up to the Arduino, and because the pump is already hooked up to the Arduino, we're going to fill this cup up right here. I already tested, the flow rate is good. To be sure, we are on 3 volts, which means this is actually, the flow rate is really good for 3 volts. 5 volts, it'll do even better. All right, that's a little better. I don't have any clamps in here, so pretty much I'm just going to press play now, and then we can go back on the computer later and see where actual time it started on. So I think we're ready, so let's go. Okay, I'm gonna one hand this one. 3, 2, 1. So you can see that flow rate is really good. All right, about to stop it. I'm gonna get it almost all the way to the rim of the cup, just so we know we got 18 ounces. Almost there. There we go. Cool. So usually for this, I'm going to stop that. So pretty much from what y'all saw, the timer started around like 7 seconds. I'll get back on the computer and put the actual time of when it stopped and the actual duration. And you can see it's pretty much at the rim of the cup, which is, I think here is actually 18 ounces, not up here. So pretty much in less than 40 seconds, we filled up 18 ounces of water, or 18 ounce, cup. And based off that, we can use that to know how much water we're going to give to each plant, as well as how long it will take to deplete this, because I believe these are about 1 gallon, and we'll just have to divide out the number for every 40 seconds. And then now from this computer right here, this program, we can calculate how much water to, or how long to run the timer on this. So this is the circuit we're going to do. We're going to keep it simple. We got the pump coming in here. We're going to do the normally open to go to the pump. We're going to ground this to the DC voltage ground. On the common terminal, we're going to bridge the DC plus, and then going to Arduinos, we're going to do pretty much a split off the wire to the solar panel direct to the Arduino. And pretty much I forgot one thing. We need a signal coming from here to right here, and that will basically turn on and off the pump when we get a signal from the Arduino, and we'll still have this LED about right here. So far, this is what we're going to do, and this will pretty much make it independent without. As well. So right now, to test it off, the test code in here is at 5 seconds delay. After 5 seconds, the pump turns on for a duration of 10 seconds. And after the duration of 10 seconds, the pump turns right back off. And once the pump turns off, it does a 10-second delay, and then it loops through and does it again. So this is how it looks. 5-second delay. And we should hit a solenoid click. Pump is running. It does this for 10 seconds. Turns off, and it's going to redo it again. All right, so pretty much as you see, this works. All right, so pretty much you see that the water pump works. The goal here with the water pump is to actually switch it now to run, I'll say every 12 hours, only run for about pretty much, I'm going to calculate it because if I have 4 ports, I'm going about 3 or 4 seconds. So this is the first iteration. It's really basic. This is a prototype. The reason why we're doing a prototype first is because we just really want to test it out. Once I test it out and make sure everything's working good, then we'll upgrade it and we're going to do some cool stuff. So something else I'm working on right here is these are my sunflowers right here. These are black oil sunflowers. I was trying to test microgreens. This right here, these plants are doing pretty good. For microgreens, I know some people eat these. I'm pretty much going to let them grow all the way out and see just how well they do. Yesterday they were drooping a little bit, as you can tell, like on this one and this. It's just because they were low on water, and this is where this system come in handy. These actually perked up really well after only giving probably like 5 or 6 sprays from a regular spray bottle of water. So running that pump that you just saw, that basically means I only have to give it pretty much 2 seconds of water a day, and these plants will be doing good. So pretty much if I gave it 2 seconds of water a day, or, you know, let's say 4 seconds of water total for every morning, every night, we could end up pretty much doing good. All right, so pretty much what we're going to do is we're going to wire, we're going to plug this into any USB port. We're going to adjust the voltage on that gold screw right here for the out plus and out minus. And there's going to be 2 wires coming out this directly to the Arduino. And that is how we're basically going to power our system. So let's get it going. So now we got this all checked out. We're pushing 5.6 volts, which is good in case we have a voltage drop. So now we're going to do is hook up 2 wires to the out plus and out minus, and we're going to wire those direct to Arduino, and we're actually going to put like 2 sockets on the end and like 2 male sockets, and then we can just plug it right into the circuit without actually having to hook it up to the board. All right, so something amazing, I was able to get this done right before sunset, and it works. So pretty much what I'm gonna do is I'm gonna short run it before the sun goes down over the mountain. It's about to do it in like 5 minutes or maybe 10. And after I show you all this, I'm just gonna update the code. All right, so as you can tell, you see the sunset. It's really about to finish really soon. So I wanna show you this real quick. All right, so it's too windy outside to hear this, so I'm doing a voiceover. The inverter is not part of the system. Only everything else you see is. All right, so let's get started. So this right here, we put a screw inside of this tubing because the flow rate was way too high on that tubing and the water wouldn't flow to all the other tubes other than trickle out. So by adding the screw in, all the other tubes are doing well. Turning on the power to the circuit, it hits that USB like we showed before. Now in 4 or 5 seconds, the water start running. Here we go. As you can see, we have a good flow rate on all the tubes, including the one with the screw. We can adjust the screw to increase the flow rate to that one tube and decrease the other, and vice versa. So if you like this video and you want to see more stuff like this, go ahead and like and subscribe to this channel, and I'll be uploading more videos. And if anyone has any project requests, just drop a comment and we'll work on it.